Negative integer exponents. All right, so when you have a negative exponent, then what that means is that it's unhappy with its location. Notice that x to the negative n is the same thing as x to the negative n over 1. So it doesn't like where it's living. It doesn't like the top apartment, so it wants to move to the basement apartment. So you swap the place and you take away the negative sign. The negative exponent has absolutely nothing to do with the sign of your answer, so it doesn't make the answer negative whatever. It just is a location movement. So let's practice that. So 5 to the negative 2, that's the same thing as 5 to the negative 2 over 1. It's unhappy with its location. Now, I'm not really swapping the place of the 5 to the negative 2 and the 1. It's just that we have a 1 times that, and what we wind up having is this 1 stays on top. This is the only thing unhappy, so I still have this 1 on the bottom, and I take away the negative sign. But what is 1 times 5 squared? It's just 25. Okay, so there are a bunch of 1s in there that are understood to be there, and I'm not trying to confuse you with all those 1s, but I do want you to understand you don't necessarily swap the location of everything. You only move the items that are unhappy. But if we had just moved the 5 to the negative 2 to the denominator, and you take away the negative sign, then you have to have something in the numerator. You can't just leave it blank like this. Look how silly that looks. So you have to place a 1 there, if there's nothing there to hold down that fraction bar. Alright, so now let's look at the x to the negative 6. It's on the top right now. It doesn't like it there, so it wants to move to the denominator. You take away the negative sign, and you have to put a 1 in the numerator position to hold that fraction bar down, otherwise it flies away. Alright, so this rule kind of goes with that last one. Again, a negative exponent just means that it doesn't like its location. So notice where x to the negative n is right now. It's in the denominator. It doesn't like it there, so we move it to the numerator. We take away the negative sign. Alright, so let's take a look at this. So this does not like its location. We're going to move it to the top. Now, that 1 doesn't just drop off and go away. It's still there. It's just 1 times 2 to the 3rd power is still 1 times 8, which is just 8. Alright, so number 2 becomes x to the 7th power. It doesn't like the denominator, so you move it to the numerator. You take away the negative exponent. Alright, so take a look at this. You have to look at what's unhappy with its location. So what's unhappy is the a to the negative 2 power. Notice the 4 is not unhappy with its location. If it was unhappy with its location, it itself would have a negative exponent. The c to the negative 5 power is unhappy with its location. The 7 is fine. The b to the 4th power is fine where it's at. So the a to the negative 2 power and the c to the negative 5th power, those suckers have to swap locations. So we're going to leave the 4 on top. We're going to leave the b to the 4th on top. And now I'm going to bring the c to the 5th on top. Notice how I took away the negative exponent because now it's happy. It likes its location. The 7 stays on bottom, and I need to pull that a squared down to the denominator. Now everything is happy with its location. Alright, so here's a recap of the first 5 rules. If you don't have these written in your notebook, you should probably hit pause right now and write them down. And here's a recap of simplifying power expressions. So again, this might be a place where you want to hit pause and write this down. Alright, so let's practice these rules. Alright, so when we have a power raised to a power, you multiply your powers together. So we're going to have x to the negative 12th. Now, this is not fully simplified. You never give me an answer with a negative exponent unless we're dealing with scientific notation. That comes next. But this type of problem, you don't give me a negative exponent ever. So I'm going to wind up doing this. And this right here is my final answer. Okay, so now on number 2, I'm going to multiply 8 times negative 3, and I get negative 24. Then I've got the same basis, so I add those exponents together. 6 plus negative 10, and I get t to the negative 4th power. Now, the t is unhappy with its location. It doesn't like living on the top, so it's going to move to the bottom. So I'm going to have negative 24 on the top, and then I've got t to the 4th on bottom in the denominator. One thing I do want you to notice here is notice that negative sign out front. That's the same thing as this. So it doesn't really matter where you put that negative sign. You could put it off to the front, you could put it on top, it's okay. You could even put it on bottom if you want. But as long as you only have one negative sign in front of that number. Alright, so let's take a look at this. So I've got several things inside a parenthesis raised to the negative 3 power. So I've got 2 to the negative 3 power. Then I've got x to the negative 5th to the negative 3. So that's x to the, multiply those together, you get positive 15. Now, the only thing with a negative exponent is this right here. So I'm going to leave the x to the 15th on top. And then I've got 2 to the 3rd power on bottom in the denominator, which gives me x to the 15th over 8. That's my final answer there. Alright, so on number 2, I've got 2 to the negative 5th, x to the positive 20th, I multiplied those together, and then I've got y to the negative 30th. Now, I'm going to circle the things that are unhappy with their location. This is unhappy, and this is unhappy. So I'm going to leave that x to the 20th on top in the numerator. I'm going to bring the y to the 30th up to the numerator, get rid of the negative in the exponent, and then I've got 2 to the 5th power in the denominator, but I need to simplify that. So x to the 20th, y to the 30th power over 32. That's what 2 to the 5th power is. If you don't believe me, grab that calculator or multiply it out. 2 times 2 times 2 times 2 times 2. Okay, now let's talk about scientific notation. Now it has to have this form right here. Scientific notation is either a really, really large number or it's a really, really small number, depending on your power of 10. So think about this. If you have 10 to the 2nd power, that means 10 times 10, which is 100. If you have 10 to the negative 2 power, you have 1 over 10 squared, which is 1 over 10 times 10, which is 1 over 100. So, this number, 100, is far bigger than 1 over 100. Okay? So, that power of 10 really does determine if the number is going to be a big number or if it's going to be a small number. Now, the thing about the number n, this has to be greater than or equal to 1, but less than 10. Okay, so the number that is in front of the 10 to whatever power has to be greater than or equal to 1, but less than 10. Alright, so now we're going to write this number, number 1, in standard decimal notation. Now here's the long way to do it. You take 10 to the 3rd power, so you would have 7 times 10 to the 3rd power is a 1 with 3 zeros after that, which is 7,000. Now, I kind of prefer to do this the little bit shorter way, and I like to just move my decimal. So your decimal starts out right there, right after that number. And if this number is a 3, then I'm going to move it to the right 1, 2, 3 places. And then I have to fill in zeros where all those values are. So you still get the same answer. So now, remember, the decimal is always immediately to the right, so I've got 7 times 10 to the negative 3. Now what this does, negative, means I'm going to move it to the left. 1, 2, 3. So my decimal goes right there, and I've got to fill in 2 values. So this is equal to 0.007. Now look at 9.48, and I'm moving it 4 places to the left. 1, 2, 3, 4. And I've got to fill in all those values. So I've got a decimal. Proper form is to put that 0 out front. I've got 3 zeros and then 948. Okay, so you might want to just read through this and take a few notes, and I'll explain this in just a second. Okay, so in this problem, number 1, I want to write this in scientific notation. So I need to have my n to be greater than or equal to 1, but less than 10. So that means my decimal has to go right there, because that would put us at 8.45, which is greater than 1, but less than 10. So 8.45 times 10. Now this had to move 1, 2, 3, 4, 5, 6, 7, 8 places. So there we go. Now on this one, I want my decimal to be right there between the 3 and the 8. That would make that number greater than 1 but less than 10. So 3.82 times 10. Now this one's getting smaller. 3.82 is getting smaller, so I need to have a negative exponent there. 1, 2, 3, 4, 5. Negative 5. Alright, so that's it for this lesson. Let me know if you have any questions.